Mhm.
Oh, I haven't had to use my board yet. Oh, we need the plasma ball. I better hold on. Oh, hey, stop that. Today's the 13th. This shouldn't take too long. This is one of those things that you get more out of it by practicing. So the 13th, 11, 13, and today is the day. I think that this is one of those things that for me is a non-negotiable. Like before you graduate from our high school, before we give you a diploma, I feel like this is something that you should have in your back pocket. It's not going to come in handy on a daily basis, but it would come in handy for any sort of math class that you might find yourself enrolled in. Could be like freshman math at L Trip or like math 1708 at like the University of Wisconsin or something. But the ability to use the quadratic formula, I think, is massive. So uh, that is that. So let's get to it. The idea behind the quadratic formula is that not all problems are like this. So this is an example of a quadratic equation that you wouldn't need the quadratic formula for. We did a whole section on these, and you guys got pretty good at this. Um, what makes that purple equation nice is that it can be factored, the F word, right? So like if I said, hey, let's solve this equation, you'd say, okay, step one, I already have it set equal to 0. Step two, I'm going to factor it down like this. I know to put my x's here. I know I need 1 plus and 1 minus, and then the numbers that I'm looking for are like this, right? I know we might be a little rusty because we took a couple days and did some other things, but by and large, that should be like, oh yeah, I got this. And then remember what makes this equal 0 is x equals -6. And then what makes the second one equal 0 is x equals 2. If that's not ringing any bells, I'd venture to say you might have missed a few days there at some point. But so that's solving a quadratic equation by what we call factoring. Today, we talk about what happens when I can't factor. And that's where the formula comes into play. If you're good at the quadratic formula, or if you're even like relatively adept at it, then from this point on, there's not a single quadratic equation that you can't solve. It's marvelous. Like literally none. If you know the formula, there's nothing with x squared in it and equal signs that could ever stump you again. So having said that, let's get into it. So here's our first quadratic equation. So based on what we've learned together so far, I assume that what you would try is this. And you're welcome to write this or not write this down because I'll just kind of spill the beans here. We're going down a dead end road here. This is what they call a wild goose chase, I believe. So if I gave you this problem and said solve it, and you were like, oh, that's easy. Seven's a prime number, so those are the only shells I can build. I know I need a positive and a negative. You could sit here, and I won't waste your time by making you go through this with me, but you could try 1 and 12. You could try 12 and 1. You could try 2 and 6. You could try 6 and 2. And you could try 3 and 4. And of course, you could try 4 and 3. And not one of them is going to produce success. So that's my, like, I'm telling you again, that's kind of my, why are we doing this? Because I don't have an option here. Like, if I can't factor it, I better have another tool to solve the equation. And that's where the formula comes in. So having said that, how do you use the quadratic formula? Well, the first thing we need is the quadratic formula, and I'll just put it up here on the board. And you do need to copy it down and be meticulous about how you copy it down. Don't hustle through it, and don't use shoddy handwriting. Make sure everything looks the way it's supposed to look. Do any of you, by chance, off the top of your head, know what the quadratic formula is? It's okay. I wouldn't expect you to. So here's what it looks like. The quadratic formula says that if you want to solve for x, it will always equal this. Always equal this. The opposite of b, that's a b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. There's absolutely no reason why that should even make a lick of sense right now, because you'd have the question, what are you talking about? Like, what are A and B and C? Do you guys know where A, B, and C come from? Want to take a shot? No? Right. They're the numbers in the problem. And so I'm going to highlight them for you, and I'm going to put little boxes around them just so you can really, really get eyes on them. That number right there with the yellow box is A. This number right here with the red box is B. And then this number back here at the end with the green box is C. And I want you to note, I'm paying great detail, a meticulous attention to the signs. So when we together are about to name A, B, and C, we want to give full respect to whether things are positive or negative. All right. Any questions so far? I mean, other than the obvious question, the question still would be, what are you talking about, man? So let's run through, and really, there's a little song that goes with it, but I'll save that for now. But the idea is that we're going to identify A, B, and C, and then we're going to plug them into that purple formula. And that's that. By the way, most often what you get are ugly answers. They're called irrational. You're not going to get little cutesy answers like x equals 4 and x equals 2/3. Those are called rational, and they're pretty rare with an assignment like what we're doing today. They'll happen. They'll come up from time to time, but usually you're going to get uglies, and that's what you'll see. And I think 3 of today's 4 examples I intended to be uglies because I want you to get used to them. All right, let's get to it. So first off, I want to make an actual identification of who everybody is. I would encourage you to do this. I realize that, again, as always, some of you might rebel and say, I don't want to. Okay, don't. But it helps. So I'm going to say right here, I'm actually going to make an explicit listing and say that A equals 7. That means that now for the duration of the next few minutes, when we go into our formula, if we see the letter A, we're switching it to a 7. What's B? It is. And what is C? It is not 12. It is -12. And again, things like that can get away from us in a hurry. You should know this about math by now. It's a very unforgiving creature, right? So step 1 is to go through your quadratic equation and identify A, B, and C. And that's what my yellow, red, and green boxes are for up there. Step 1.2 is obviously make sure you have a copy of the quadratic formula laying around someplace, right? Okay, so let's get to it. And you ask lots of questions. Don't worry, you'll be practicing this a lot today and tomorrow. But just ask a lot of questions as you go. There are no stupid questions. I know that sometimes people preface their questions with, this is a stupid question, but no, if you need to know something, just ask. So here we go. So I'm going to switch colors back to purple, and here we go. We're going to say x equals. Now, the very first step in the quadratic formula, I'm going to point to it with a white arrow, is right here. And you might think that that's no big deal, but I'm going to try to coach this to you like in little steps. So the first thing you have to do is take the opposite of B. Some people call it negative B, like the song I'm going to teach you does say negative B, but I think of it as the opposite of B. And what is the opposite of 4? Negative. It is. So the very first thing we're going to write into our answer is -4, and then we're always going to put this plus or minus sign right afterwards. All right. What that means is there's going to be 2 answers. One of them is going to be -4 plus whatever comes next, and the other answer will be -4 minus all the stuff that comes next. So you are getting a couple of answers out of this. The next thing you're going to do is you're going to build a square root sign, and you're going to make that square root sign longer than you probably think you need it to be. If you think you've made it kind of like, well, that's pretty long, you probably want to add another little bit to it because we have to do a lot of math inside of there. We ready to move on? So I'm going to erase my white arrow, and the next step, the next thing you have to be good at is right here. Again, go to the top of the screen where that white arrow is pointing. If you're good at taking notes, make sure you write this down. The answer to that problem right there, I'll put a little white egg around it. The answer to that problem is always positive. Why is that? Why would that number have to always be positive? Because it's squared, right? And so I had a guy just today, honestly, on a quiz that had nothing to do with the quadratic formula. Someone in algebra 2. We just were using the quadratic formula to find a zero of a fourth degree polynomial function. And homeboy clearly typed these things into his calculator and forgot to use parentheses. So he was saying things like -5 squared is -25 and stuff like that. So make a note of that, mental and on paper, that that number that's going to go right there is always going to be positive. Are we clear? No matter what your calculator tries to tell you, if you hold it up and go, but my calculator says -169, it's not the calculator's fault. You forgot the parentheses. All right, let's get to it. So first up is b squared. And what is b? So what is b squared? 16 goes right here. So we've done two things so far. And I'm really just trying to walk you through this as slow as I can. So step one was to do the opposite of b. Step two was to do b squared, which again is always going to be positive. The next step is to do this. And I'm telling you, I've been doing this long enough. This will help you. Go like this. Watch my pen. Put -4 and then put two sets of parentheses after it like this, and don't put anything in them yet. Trust me. We'll come back to that later. And then I'm going to draw a big long fraction bar like this. And I'm still avoiding those parentheses. If that drives you nuts, well, you'll just have to deal with it because it's what I do every time. And then I'm going to go to the bottom of the formula. And what does the bottom say to do? 2 times whatever a is. And what's a? So I'm going to do 2 times 7 and put 14 there. I know this looks completely nuts, but at some point, it probably won't be today, but maybe tomorrow, maybe Wednesday, you're going to see it, hopefully, and kind of get a glimpse and go, all right, I kind of buy it, you know? It looks so weird and like like you're lost in the forest, right? You can't see what's going on. Now, what we're going to do is we're going to go back and we're going to backfill those two sets of parentheses. What letters go in there? A and C. It says so right up here in the quadratic formula that there's A and C that go there. So in the first parentheses, what are we going to put? 7. And in the second parentheses, what are we going to put? Good. We've done very little math so far. Honestly, we've done the opposite of 4, which was like, whoa, wipe the sweat from your brow after that. And then we did 4 squared, which I think was pretty simple. And then on the bottom, we did 2 times 7. Like, really? So to get to this point, we did very little. But I still ask, do you have any questions yet? Good. Now comes the part where most people are going to screw it up. And I don't mean that you're going to. I'm saying that if mistakes happen, most of the time they happen what I'm about to try clumsily to explain to you. So I wish us all luck. This minus sign right here isn't always going to stay as a minus sign. What makes minuses turn into pluses? Putting another negative after a minus sign makes the minus say, whoa, hold on, you're about to negative me up. And so if I'm already a minus and I crash into a negative, then I become an addition sign, right? So about 50% of the time, that minus that yellow arrow is pointing to up there is actually here in a moment going to morph into a plus sign. Got it? Half the time. And what it's contingent upon is this. I'm going to draw a little green arrow and I'm going to hunt and I'm going to say, I found you. You see this negative down here? I mean, I know you see it. I don't mean to ask stupid questions, but that negative and that minus, the yellow and green arrows, at some point they're on a crash course to find each other, because when a minus just starts mashing his way through, he's going to find him eventually. So what's going to happen now is what this actually says is -4 plus or minus the square root of 16 plus 4 times 7 times 12 all over 14. I know I won't normally show that whole step over again. I did it this time just so you can see that what happened was this minus and this. Can someone take their phone off their desk so I don't have to listen to it? Yeah, I don't care that you're getting. No, it's okay. Just the vibration on the desktop is really annoying. So is that you, Aiden? Oh, better. All right, thanks, man. So again, do you see what happens half the time? All right. So what's going to happen now is you're going to perform the operations in this green box. And I'm not drawing this green box accidentally where I am. I'm being very, very purposely meticulous. Your job is to multiply the three numbers inside the green box. It's not distribution. You don't do like 4 times 7 and then 4 times 12. That always freaks me out. You just do, like, type it in your calculator. You just do 4 times 7 is 28, and then 28 times 12 is like 336 or something like that. Nice. So what happens there is now what I have is this. I have -4 plus or minus the square root of 16 plus 336 all over 14. And we're almost ready to finish now. And then you'll see why we did what we did the last couple days. I hope. I mean, if not, you just haven't been paying attention. But the last thing left to do is add those numbers inside the square root sign, right? And what is 16 plus 336? Good job. So we have -4 plus or minus the square root of 352 all over 14. And that day when I almost got you to do the quadratic formula, this is what stopped me. Not that you're interested in what goes on in my mind, but this is exactly why I pumped the brakes that day and said, we can't do that yet. We haven't talked about square roots. But now we detoured, and I'm assuming at this point that you finished both of the square root assignments. So if that's true, then you should be able to now take this square root right here. See this guy? You should be able to take him out and work with him. So I'm going to need your help with this. I know Aubrey's our resident expert on this, but what we need to do is break down collectively as a class, we can work together. We need to simplify that square root. So I'm assuming you all have calculators. And so at this point, we just start, divide and conquer. We just start dividing 352 until we come up with the best combination of two numbers that multiplies to make 352. Like, for the record, I know that 4 times, I want to say it's 88 will work, but why do I know that that's not the best I can do? Because 88 has more to give. Gosh, way to use those words. That was good stuff. So I look at 88 and say, you still contain a square. So I know that that was not the right choice. So keep dividing 352 by the numbers on our red list until you can tell me what the best combination is. I don't like 32 times 11, and I'll tell you why. And I think you already know this, Aubrey. 32 and 11, neither one of them is on my red list. So while it is an awesome combination, it doesn't do me any good. So you went a little too, you hit that accelerator a little bit too firmly. You got to pump it back a little bit. Okay, 16 is the best we're going to do. So 16 times what? Say it again. Nice. And I know that that's the best combination because 22 has nothing else to give. 22 is a collection of 2 times 11, which does me no good, right? So this is where this skill comes in handy, is that when you get to the end of the quadratic formula, that's when you kind of go, oh, so I got to simplify that root. And then we're not quite done yet, but what is the square root? What happens when that red number breaks out of jail? What does he become? He becomes 4. So watch what I'm going to do. I'm going to write 4 root 22. And then because I can do this kind of cool stuff on the TV, I'm going to grab it and I'm going to put it back up in there where the old square root used to be. And you probably just have to do that with your pencil. Are you still with me? Finally, we're going to draw a Dorito. I don't know why I started calling it a Dorito a few years ago, but it seems to stick. And when something sticks, you feel like, well, I might as well keep saying this because um, people remember this stuff. I want you to look at my pen, and I'm drawing like this guacamole colored, guacamole flavored Dorito. Y'all see him up there, of
That
course.
sounds disgusting.
I bet a guacamole Dorito would be just wonderful.
No.
FYI. So what you do now is you ask yourself inside the Dorito, this is just basic. This is like a fourth grade math question. So can you think of what's the largest number that all of the numbers in the Dorito can be divided by? They can definitely be divided by 2. So why don't we go ahead and take them all and divide them by 2? So if I divide them all by 2, here's what they become. The -4 becomes -2. And then we copy down the plus or minus. What does the +4 in front of the root become? 2. And then on the bottom, what is 14 divided by 2? Stick an x equals in front of that, put a box around it, and that's it. It's a lot to digest, huh? Now we're going to do this again a few times, but we're not going to take as long. All right, that was a long problem. There's a reason for that. So on to the next one we go. Here's your next math problem. Oh, there it goes, turned off. Make sure you write this down and stay current so you don't have to be the can you scroll back up kid. So here we go. We're all good. We're set equal to 0. By the way, I don't think I said this explicitly. So here it is on recording. You must have it set equal to 0 to find A, B, and C, right? All your stuff, just like before, has to be collected under one side. Okay, so what's A in this problem? A is 6. What's B? And what is C? Nice. Let's get to it. I don't expect you to have memorized the quadratic formula yet, but here we go. X equals, what's the first thing we're going to put? -B, or opposite B. And in this case, what is the opposite of B? -4. So just like last time, we're starting out with a -4, and then we're going to put plus or minus a very long square root sign. And the reason is because there's a ton of stuff you got to do in there. What's the first thing we do once we venture into the square root sign? You square B. What is B squared in this case? Bet it is. And then the next step, and again, you take it or leave it. Having done this 27,000 times with teenagers, I think I have found a helpful way, and it is this. It is to put -4 and then draw 2 empty sets of parentheses. Give your brain a break. Don't try to fill those in. And the reason I think what I figured out is that people put the wrong numbers in the wrong places because they're all wrapped up in other stuff. So let's just take a break and then go to the bottom of the fraction, because this is like third grade stuff on the bottom. What is 2 times A? 2 times 6. So we just stick a 12 down there. So give your brain a few second break, and now we're charged up. Let's go back up and plug in our parentheses. What am I going to put in the first empty set? That's A. Good job. 6. And what goes in the back set? Nice. So you tell me, and I always, on the second example, I feel like I'm ready to ask this question. This minus sign that I'm pointing at with the green arrow, is he going to stay as a minus or switch to a plus? He's going to switch because, again, you see the crash course coming. You see that there's another negative on down the way. So here we go. So what's happening inside of there is really this. If you just take these 3 numbers, I'm going to draw like a red bubble cloud around them. Forget the negative for a second, if you'd be so kind. Using your calculator, what's 4 times 6 times 16? Say it again. 384. So we have 16 plus 384, which comes out to 400 on the nose. So it is, yes. And I was a little bit hesitant. I thought, should I make this my second example or should I wait and make this the third? And there was some lottery held in my brain, and I decided, let's make it example two. I wanted you to see a problem like this. And like Aubrey pointed out, 400 is not just some number. 400 isn't just something that happens. 400 is a spectacular number. Why? It's on the red list. And so I want you to see what's about to happen. The square root of 400 does not require like a simplifying it. You just do it. This isn't a make a tree problem. It's just 20. So the next step is going to say this. X equals -4 plus or minus 20 over 12. You might say, what happened to the square root sign? It's gone because I don't need it anymore. I was able just to literally take the square root of the number. You're going to hear me now refer to this as a pathway. I'm going to write this up here. This is called a pathway problem. And by the way, that is not an actual mathematical term. It's just, again, one of those things I've settled on doing this all day with people. Here's what I mean by pathway. And you can only do this when the square root goes away. Are you ready? I'm going to circle a sign, and that determines a pathway. So I circled the plus, and that is now a pathway. And we're just going to do the math. You're going to help me with the math. If you follow the red pathway, what is -4 plus 20? So one of my answers is 16 over 12, which I will reduce. What can 16 and 12 both be divided by? Leaving us with 4/3. One of our answers is x equals 4/3. Now I'm going to switch colors, because why not use colors if you've got colors? Brilliant colors on a black television in a dark room, it's a no-brainer. The other pathway is the minus sign. You see it? Help me with my math. What's -4 minus 20? It is not 24. It is -24. And I put it over 12, and again, I simplify. What is -24 over 12? -2. So my other answer down here at the bottom of the TV is x equals -2. Now, no time ever in the history of Mr. Ahern's 28-year teaching career has any kid ever said this. Well, that's weird. How come we got those answers? What does that mean? So I always ask it for you. What does it mean? Why did we get answers like that? And when the last time we got those weird things with like -9 plus or minus 3 square roots of 58 over this, like, does anyone want to take a shot at what this means? Mm-hmm.
They put them over each other because they can't divide each other. Yes, no, they didn't know.
Nope. Nope. There is zero reason for you to know the answer to this question, but I'm going to throw this up. And from this point on, if this happens to you, you're using the quadratic formula and you realize that you got these kinds of answers, I want you to now see, if you're interested, I want you to see what it means, because I think it's interesting, and I hope you do too. Going back to the original problem, it means this. If I gave you this math problem 2 weeks ago, it means this. It means you could have factored it. And you may not find that to be even remotely interesting as a revelation. But when you go through the quadratic formula and the square root just dies and you get cool answers like a half, 2, 5, -3, something, whatever, that means that we could have factored it. And check it for yourself. So like, look at this. What's 3x times 2x? 6x squared. And then let me do a green one for you. What's -4 times +4? Just like that. Try, you need to wake up. We're all sleepy here. Now take a good look at this. What does purple guy make? Negative 8x. And what does white connector make right there? Add those together. Negative 8x plus 12x. Jackpot. I'm only showing you this because I want you to be aware that it's going to happen. It doesn't mean that you're a bad person. It doesn't mean you picked the quote wrong method. I just want you to be able to make that connection that when the square root sign dies and you get normal answers, all it means is, oh, I could have factored it from the beginning. That's where those answers would have come from. So like if I set this first one, let me underline him in purple for you. If I set this and I said, hey, what answer do you get out of that? You'd go, oh, I get x equals 4/3. And then if you did it out of this one, you'd go, oh, I got x equals negative 4/2, which equals -2. And if you're paying attention, this answer and this answer should look very familiar because we just got them using the quadratic formula. If there was a that makes sense scale of 1 to 10, 1 is like, I have no flipping clue what you just said, and 10 is I really get it. My hope with an explanation like that is that you're at least floating around a 5, that you can kind of see that connection. All right, this time I'm going to put a problem up and I want you guys to do the first step and then I'll get caught up to you. So I'm going to give you about a minute to just plug the numbers into the purple quadratic formula and then I'll get caught up and we'll see how if you made any mistakes. So here we go. Just to make sure we all get off on the right foot, I want to make sure we're in unanimous agreement on this problem. What is A? Fantastic. What is B? Doubly fantastic. And watch out here. What is C? It is not 6. Yeah, and that's where the catastrophes can happen. So remember, pay attention and respect the minuses. They become negatives. All right, guys, there's your 3 numbers. Go ahead and plug them into the first step, and I'll get caught up in about a minute. And you can go a little further than 1 step if you want to. Go as far as you want. I'm going to start writing on the TV, but you just feel free to continue. And when you're ready to look up and kind of compare your notes with mine, then do that, but only when you're ready. So. I'm going to go this far. And considering that we just started this a half an hour ago, if you made it this far, kudos to you. That's a lot to ingest in one sitting. I just circled the signs so that we could all make sure that we're clear as to why I put a plus up there. Because that minus that I circled and that negative, they're going to come together and make sweet math loving and make a baby plus, right? Yep, 48 came. You got it. 4 times 2 is 8. No, make sure all you want. That's gorgeous. So you good to there? Nice, good, good. Are we feeling good about getting to this point? All right, so this is where the last couple days of work come in handy. And now we find ourselves with clearly 148 is not on the red list. So this isn't going to be a pathway problem where we get like x equals 5 and x equals. We're getting, this isn't ugly. It'll be a Dorito eventually, but for now, what it is we have to be really, really good, all of us. That's why we practice at what do I do with the square root of 148? So let's see. I break it into a square root of two numbers that multiply together. Have you guys found the greatest combination yet? What do you think it is, Miss Orozco? I think you're right. I think that's it. We found it. It's actually relatively unexciting, but the best you're going to do is 4 times 37. And that feels like, man, I wish I could go bigger, but 37's as dead as they come, right? 37 is super dead. So what does root 4 root 37 become? What is nice job, Foxy. So again, because I have this cool technology and I can do stuff like this, I'm going to grab that and throw it back up like that. It's always going to be the part where you take the radical out, mess with it, put the better version back in, boop, carry on. And now it's time to draw the Dorito. And you don't have to draw the Dorito. If you went to some college class and your instructor was like, who taught you this? You could tell them it was me, and he'd probably have me in for like a psych eval. Because like it's not really part of the like part of the deal. I just do it because I feel like I want to draw your attention to what has to now happen. All of those numbers in the Dorito have to agree to this or it doesn't happen. If one guy sits out, they all sit out. Can they all be divided by anything? Yeah. 2. So our final answer is going to be x equals what? Uh-uh. Because the 2 got divided by 2, right? So all of these numbers that I'm putting check marks through are not going to be there anymore because they're all getting divided by 2. It would be 1, and I'm not going to put it. I'm just going to put root 37 because I don't like to multiply things by 1, and then I divide it by 2. This is going to be a Sharia question, and I have no issues with this at all. No, seriously. Is it okay if I put a 1? You see my red 1? Is that okay? You bet it's okay. Absolutely. It really is okay. No, it's okay if you put it, but you don't need it. And so it's okay if you don't. Last example, and then it's work time, which I've taken up most of your hour, but rest assured there'll be a lot of work. So last one, and then it's work time. And after we finish this, I just have one closing comment that you might think is like, oh, he's just taking more time. It'll help you a lot. Yeah. Yes. You guys, did anyone actually see A up here? It's right there. Do you see it? It is 1. Yes. So when you can't see it, it's a 1. What's B?
Whoa, I just wrote B backwards.
Yes, but not yet. So we're not, I decided to not cross that bridge today because I just wanted to get everyone solid on having an A, having a B, having a C. But if that happened, B would be 0. Oh. Yeah. What's B again? It's not 10, it's negative 10. And what is C?
Is that a 6? Does it look like a B?
Sorry, I wouldn't do that to you. I wouldn't put like x squared minus 10x plus B. That would just be weird. All right, same drill. You can kind of work and I'm going to work and just try not to look at mine until you're ready to say, how did I do? Right? Don't just copy mine. Let's see if you can nail it. So we're off. So in a perfect world, we all made it at least to this point. Everything went well. So I took the opposite of b, and since b was already a negative, the opposite became a 10. Then I squared it and of course put 100. Notice I circled that minus, and I think for the first time today, that minus stays as a minus. Why? Why doesn't he change? Yeah, because there's no negatives back there. So if the minus, like, I'm never going to see a negative, and he's like, I guess I'll just stay as a subtraction. And then, like Peyton asked earlier, the 24 up there comes from these numbers that I'm underlining in green being multiplied together. Heck with the signs. 4 times 1 times 6 is 24. And then 100 minus 24 is 76, and we arrive at this point. And now it's time for us to take this square root of 76 off to the side and say, okay, I need to find a better version of you. You're the square root of what times what? What would we multiply to make 76? There is one good combination.
What was it,
8 and 7 make 56. That's the only combination that will do us any good at all. 4 times 19 makes 76. And why it's so spectacularly beautiful is because 4 is on the red list, and we know it's the best combo because 19 is dead as a doornail, right? So when that 4 breaks out of jail and becomes a 2, then we're going to have 2 root 19. So here we are. We have 2 root 19. And again, I'm going to take that now, that's like new and improved radical, and put it back where the old version of himself used to be. And what's it time for now? The Dorito, right? Draw that triangle in there so you can let yourself see. And notice that your Dorito never includes what's in the square root, right? He's totally off limits. And so what can 10 and 2 and 2 all be divided by? Go ahead. Yeah.
And then it would just be positive or negative, plus or minus.
Almost. You misspoke a little bit, but yes. Here's what the answer will actually look like when you're done. Now, you might say to yourself, what in the heck happened to this whole over 2a? Well, let's think about this. When 10 got divided by 2, he became 5. What happened with the green check mark when 2 got divided by 2? A 1 that no one really needs, right? And then what happens here with the yellow check mark, the 2? 2 divided by 2 is? It's 1, right? And again, what's the point of putting blah, blah, blah over 1? There isn't, right?
But on your machine.
So that's that. I have to return a phone call. That was my realtor, and we're getting carpet in our house that we're selling. So I'm going to have you guys be off the hook here for today. So we only have a few minutes left. So tomorrow will be a nice long work day, okay? All right, guys.